In 1986, the rhythm of the British building site was permanently altered. Inside a boardroom, the industrial conglomerate Hawker Siddeley made a decision that erased an independent engineering force. Petter, the company that had powered Britain's muddy, freezing, and unforgiving construction sites for decades, was suddenly forced into a merger with its oldest rival, Leicester. Soon after, the historic Staines factory gates were closed. At the time, this was a profound shock. Petter's single-cylinder, air-cooled diesels, like the legendary PH1 and AA1, were not failing on the job. They were the undisputed heartbeat of the nation's infrastructure. They ran the Winget cement mixers, spun the water pumps, and powered the off-grid generators. Yet almost overnight, the independent badge vanished. The local service networks that had kept these cast iron blocks running with nothing but a spanner and basic oil changes were abruptly absorbed into a new corporate reality. The paradox was absolute. The Petter engine block was almost indestructible, but the British industry around it was completely fragile. But the real story of Petter is not only the story of a factory closing in Staines. It is the story of how Britain powered its daily work before power became silent, disposable, and battery-powered. Every week we tell the stories of British engines, factories, machines, and industrial names that once taught the country what power sounded like, and what happened when the market moved on. Subscribe if that history matters to you. The story of Petter begins not with nostalgia, but with a specific absence. In the rural workshops of Yeovil in the early 20th century. The story begins not with nostalgia, but with a specific absence. In the rural workshops of Yeovil, Somerset, at the end of the 19th century. Before the electrical grid reached into the deep British countryside, power was an intensely physical problem. If a farmer needed to pump water, cut chaff, or drive a milking machine, the choices were brutally limited. They could rely on human labor, which was slow. They could use horses, which required constant feeding and care. Or they could buy a steam engine, which was massively expensive, heavy, and demanded a dedicated operator to manage the coal and boiler pressure. Rural Britain did not need massive industrial power. It needed something small, independent, and cheap enough to sit in a shed and run all day without a complaint. In 1895, twin brothers Ernest and Percy Petter, working in their father's Yeovil ironmongery business, recognized this gap in the market. They did not set out to build a global industrial empire. They simply wanted to build a machine that could replace a horse. Their answer was the internal combustion engine, an engine that burns fuel inside its cylinders to create power. But the Petters did not focus on high-speed racing or luxury cars. They focused on utility. By 1896, they had designed a simple, horizontal, single-cylinder oil engine aptly named the Handyman. The Handyman was rudimentary, but it proved a fundamental concept. Rated at just 1 horsepower, a measurement of how quickly an engine can do work, it was small enough to be hauled into a barn and simple enough to be understood by a blacksmith or a farmhand. This was a critical moment for the British engine market. The Petters understood that an engine was useless without a system to support it. They began selling their engines through agricultural machinery dealers. The local ironmonger, who previously sold plows and horseshoes, suddenly became the parts counter and service network for a new mechanical age. By the time the First World War ended, the demand for small, reliable power had exploded. In 1922, operating out of their expanding Nautilus works in Yeovil, Petter launched the engine that would make them a household name in rural Britain, the M-Type. The M-Type was a stationary engine, an engine designed not to move a vehicle, but to stay in one place and drive external machinery like pumps, generators, or belts. Available in sizes ranging from 1.5 to 10 horsepower, the M-Type was a 2-stroke engine, an engine that completes a power cycle in 2 piston strokes, often making high power for its size but with emissions and oiling trade-offs. In the case of the M-Type, it operated as a hot bulb semi-diesel. To start it, a farmer had to use a blow lamp to heat a metal bulb on the cylinder head until it glowed red. Once hot enough, the fuel was injected, ignited by the heat, and the heavy cast iron flywheel would begin to turn with a deliberate, rhythmic chug, chug, chug. This was not sophisticated aerospace engineering. It was agricultural survival. In a dark, damp Somerset shed, an M-Type could be bolted to a wooden block, attached to a flat leather belt, and left to run a water pump for hours while the farmer tended to other work. The engine block, the main engine structure that holds the cylinders and major internal parts, was cast thick enough to absorb immense punishment. If it broke, it did not require a specialized engineer from London. It could be stripped down on a workbench using basic spanners. The M-type taught a generation of British workers how to trust internal combustion. By the late 1920s, Petter was producing tens of thousands of engines. The factory floor in Yeovil became a massive operation of casting, machining, and assembly. But as the 1930s approached, the mechanical world was shifting. The old hot bulb engines, which required a blow lamp to start, were becoming obsolete. The market demanded machines that could start instantly from cold. The industry was moving toward the true diesel engine, an engine that ignites fuel by compressing air until it becomes hot enough to burn diesel fuel. Diesel power offered better fuel economy, greater thermal efficiency, and immediate starting. Petter adapted, pivoting their massive foundry capabilities towards cold-starting diesels. They developed new designs, expanding from agricultural sheds into maritime auxiliary power and industrial generation. By the eve of the Second World War, Petter was no longer just a rural ironmonger's side project. It had become a cornerstone of British mechanical infrastructure, producing power units that the military, the railways, and the construction industry were beginning to view as indispensable. The blueprint was proven, the factories were scaled, the service network was in place across every county in Britain. Now Petter just needed a world rebuilding itself from the ground up to realize exactly how many small diesels it actually required. When the Second World War ended, the British landscape was scarred and exhausted. The nation faced a monumental task of reconstruction. Millions of new homes, miles of roads, and vast new industrial estates needed to be built. But a post-war British building site in the late 1940s and 1950s was a hostile environment. It was often a field of deep mud, disconnected from the national electrical grid, exposed to freezing winters, and operated by a workforce that needed tools to work immediately, every single time. The problem was not just making power. The problem was making power that could survive the people using it. Until this point, many small industrial engines were liquid-cooled, an engine design that relies on a radiator and water jackets to dissipate heat from the cylinder. On a large stationary factory generator, liquid cooling made sense. But on a muddy construction site in Coventry or Birmingham, it was a massive liability. In the depths of a British winter, if a tired laborer forgot to drain the water from the radiator at the end of the shift, the water would freeze overnight. Ice expands, and by morning, the expensive cast iron block would be cracked wide open, rendering the machine entirely useless. Furthermore, radiators could be punctured by flying debris, and water pumps could seize. Petter understood that for an engine to become the definitive power unit of British Reconstruction, it had to be entirely idiot-proof. It had to be immune to the weather, immune to neglect, and immune to the heavy-handed nature of plant hire. The breakthrough came with the aggressive shift toward the small air-cooled diesel engine. An air-cooled engine, an engine that uses cooling fins cast into the cylinder barrel and a flywheel fan to blow ambient air across the hot metal, eliminated the radiator, the water pump, the hoses, and the threat of frost damage in one engineering stroke. In the late 1940s and throughout the 1950s, Petter introduced the Ava series and shortly after, the legendary PH series. The Petter PH1 was a single-cylinder diesel engine that would go on to define the sound of British manual labor. It was not designed for speed, refinement, or quiet operation. It was designed to run constantly, at full load, surrounded by abrasive cement dust and driving rain, without ceasing. The engineering brilliance of the PH1 lay in its absolute mechanical stubbornness. The cylinder head, on the upper part of the engine that helps seal the cylinders and contains the valves, was heavily finned cast iron, capable of absorbing intense heat without warping. The internal tolerances were loose enough to keep the engine turning, even when the oil had not been changed for months. Starting a Petter PH1 on a freezing January morning became a national ritual. Because it was a true diesel engine, relying on immense pressure rather than a spark plug to ignite the fuel, the cylinder pressure was too great for a human to overcome simply by turning a handle. Petter engineers solved this with a decompression lever, a mechanical switch that held the exhaust valve open, destroying the compression. A laborer would insert a heavy steel starting handle into the camshaft, flick the decompression lever, and begin winding the heavy flywheel to build momentum. Once the heavy iron wheel was spinning fast enough, the operator would drop the lever. The exhaust valve would snap shut, the air inside the cylinder would violently compress, heat up, and ignite the injected diesel with a loud percussive crack. Once it started, a Petter PH1 would sit in the mud and produce a steady, rhythmic chug 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 that could be heard echoing across every housing estate in the country. It was the sound of a Winget cement mixer turning. It was the sound of a Godwin water pump draining a flooded trench. It was the sound of a dumper truck hauling rubble. But Petter did not stop at heavy cast iron blocks. By the early 1960s, the company, now operating heavily out of a large factory in Staines, Middlesex, recognized that the market was demanding even more portability. The heavy PH engines were brilliant, but they required a crane or several strong men to move. In 1964, Petter launched an engine that completely redefined the scale of utility diesel power, the AA1. The AA1 was a revelation. It was one of the world's first ultra-lightweight, high-speed, air-cooled diesels, producing 3.5 horsepower, a measurement of how quickly an engine can do work. It revved up to an astonishing 3,600 RPM. But its true breakthrough was its construction. Petter heavily utilized aluminum alloys for the crankcase, the cylinder head, and the cooling fan. The result was a diesel engine that weighed just 43 kilograms. It was small enough and light enough that a single worker could lift it out of the back of a Bedford van and carry it across a field. The AA1 proved that a diesel engine did not have to be a massive, stationary anchor. It could be a highly mobile power unit. Suddenly, agricultural dealers, plant hire companies, and marine suppliers had an engine that could be bolted to almost anything. This hardware breakthrough created a massive service system. The Petter engine reached the British public through plant hire yards, companies that bought equipment to rent out to local builders. These yards demanded Petter engines because they knew the local motor factors carried the fuel filters, and the local mechanics knew exactly how to strip the block down using standard spanners. A machine shop in the Midlands could overhaul a tired Petter in an afternoon. The service manual, often stained with oil and diesel, was written in a mechanical language that the entire country understood. Petter had engineered an ecosystem of trust. If a piece of machinery was painted in factory green or industrial yellow, and it had the Petter badge riveted to the cooling shroud, a site foreman knew it would start in the cold, run on poor quality fuel, and survive the winter. The engine was no longer just a piece of farm machinery. It had become the default heartbeat of British construction. By the early 1970s, the Petter badge was no longer just a piece of agricultural machinery. It had become a permanent fixture of the British landscape. The massive Staines factory, sprawling alongside the River Thames in Middlesex, was operating at an industrial scale that the founding brothers could never have imagined. Thousands of small diesel engines were cast, machined, and assembled every week. The factory floor was a deafening theater of British volume manufacturing, a maze of foundries, cutting tools, and assembly lines smelling of hot metal, cutting fluid and diesel exhaust. Petter had become a highly profitable cornerstone of the Hawker Siddeley Industrial Group, exporting power units to over 100 countries. But its heart remained firmly in the British mud. Out in the real world, the lightweight AA1, the legendary PH series, and the larger twin-cylinder PJ engines were doing the physical heavy lifting of a modernizing nation. If a new council estate was being built in the Midlands, a fleet of Thwaites dumper trucks powered by Petter diesels hauled the earth. If a motorway was being laid in Yorkshire, Compair air compressors driven by Petter blocks broke up the old tarmac. And on almost every corner of every building site in the country, a Winget cement mixer turned endlessly, driven by the familiar rhythmic drumming of a single-cylinder Petter. The reach of the engine extended far beyond the building site. Down on the coast, Petter marine diesels were being fitted into canal narrowboats, fishing smacks, and even the heavy wooden lifeboats of the RNLI. When a vessel lost its main power in the dark waters of the North Sea, a hand-cranked petter generator was often the only thing keeping the radio alive. Inland, the post office telecommunications network relied on petter diesels to run backup generators for remote telephone exchanges, ensuring that the country stayed connected during the frequent industrial power cuts of the 1970s. In a Britain where a small industrial engine could decide whether a winter housing foundation was poured, a flooded municipal trench was drained in time, a rural dairy farm kept its milking machines running, or an off-grid lighthouse kept its backup generator spinning. Power was not an abstraction. It was cast iron, diesel fuel, manual labor, basic spanners, and absolute mechanical trust. This trust was built on a massive, invisible service network. The true genius of Petter during its peak was not only the metal, it was the ecosystem of repair that surrounded it. Petter engines were supported by an army of independent agricultural dealers, plant hire companies, marine fitters, and local motor factors. In a typical rural workshop, an oily, dog-eared Petter service manual sat permanently on the bench. The parts bins were stocked with genuine head gaskets, fuel injectors, and replacement piston rings. If a PH1 finally lost compression after 5 years of daily abuse on a muddy building site, the plant hire yard did not throw the engine away. They assigned an apprentice to strip the block down. Because the engine relied on pushrod overhead valves, an engine designed with valves in the cylinder, head operated by simple metal rods. A mechanic could rebuild the top end in a single afternoon. Petter had created a national habit. They had taught British industry that a small engine was an investment, a permanent tool that could be endlessly repaired, overhauled, and sent back out into the rain. The brand was so dominant that its distinct exhaust note became the unofficial soundtrack of British work. It was a golden era of manufacturing scale, dealer confidence, and mechanical permanence. The engine had taught Britain to trust a sound. It had not solved what would happen when that sound became too expensive to keep. This mechanical ecosystem extended far beyond local plant hire yards. Under the ownership of the Hawker-Siddeley Group, Petter became an export powerhouse. The heavy cast iron blocks that survived the freezing mud of Yorkshire were shipped by the thousands to the Middle East, Africa, and South America. They ran irrigation pumps in remote deserts, powered backup generators in tropical heat, and drove agricultural feed mills in places where a mechanical failure meant a loss of livelihood. But despite this global reach, the soul of the engine remained fiercely British. At the Royal Agricultural Show at Stoneleigh, the Petter stand was an annual pilgrimage for farmers, fleet operators, and local dealers. They did not come to look at sleek, aerodynamic styling or silent running. They came to listen to a row of naturally aspirated engines that draw in air at atmospheric pressure without a turbocharger or supercharger, running on test stands producing that familiar, heavy rhythm. By the late 1970s, the Staines factory had achieved a level of industrial scale that felt permanent. The product lineup was vast. It ranged from the tiny aluminum block AA1 used on lightweight water pumps up to the massive, multi-cylinder, heavy diesels used for marine propulsion. But the core philosophy never changed. A Petter engine was built to be heavy enough to absorb punishment, loose enough to tolerate neglect, and simple enough to be fixed in a field. The physical reality of this era was defined by the overhaul, a major service process where an engine is taken apart, inspected, and rebuilt to operating standards. In the 1970s, replacement culture had not yet taken hold of British industry. When a Winget cement mixer stopped running on a Friday afternoon because the Petter PH1 had finally ingested too much cement dust, the engine was not thrown in a skip. It was unbolted, lifted into the back of a Bedford lorry, and driven to a local machine shop. Inside that workshop, the process was entirely predictable. The mechanic would drain the black, thick oil. They would remove the heavily finned cylinder head, inspect the bore, and order a set of oversized piston rings from the local factor. The parts catalog, invariably greasy and dog-eared, proved that Hawker-Siddeley understood the aftermarket. Every single component, from the heavy cast iron flywheel to the smallest copper fuel washer, was available over a parts counter in almost every county in Britain. This was the peak of British mechanical trust. A site foreman did not need to understand thermodynamics to trust a Petter. They only needed to know that if the decompression lever was flicked, the starting handle was turned with enough aggression, and the fuel line was blood of air, the engine would fire. In this era, Petter was not just a company making metal boxes that burned diesel fuel. It was an institution of British work. It had captured the agricultural market, the marine auxiliary market, and the construction market so completely that competing against it seemed impossible. The factory was running at full capacity. The dealer network was deeply entrenched. The exhaust note was recognized on every building site and farmyard from Cornwall to the Scottish Highlands. Petter had taught a generation of British workers to trust a specific sound. It had not prepared them for a market that would suddenly demand that sound be silenced. The decline of the Petter Empire did not begin with a catastrophic mechanical failure, a sudden bankruptcy, or a sudden loss of horsepower. It began with a quiet, almost invisible shift in a British plant hire yard in the late 1970s. For decades, the purchasing decision for a site foreman had been simple. If they needed a machine to turn, pump, or generate power in the mud, they bought a Petter. But as the 1980s approached, the catalogs on the manager's desk began to change. Alongside the familiar heavy cast-iron British blocks, new brochures appeared featuring brightly painted compact engines from Japan. Names like Yanmar and Kubota. This was the first small crack. It was not that the Petter had suddenly become a bad engine. It was that the definition of a good engine was fundamentally changing. The Japanese manufacturers did not try to beat Petter by building a heavier, tougher cast-iron block. They bypassed the British philosophy entirely. They introduced ultra-compact, high-revving micro-diesels. Where a Petter PH1 relied on massive displacement and a heavy flywheel to produce a slow, rhythmic chug, a Kubota multi-cylinder diesel used precise, lightweight internal components to spin smoothly at high speeds. This shift exposed the hidden trap of Petter's greatest strength. The heavy cast iron that made a Petter indestructible also made it violently abrasive. A single-cylinder Petter vibrated intensely. On a heavy steel Winget cement mixer, this vibration did not matter. But the construction industry was evolving. Sites were beginning to use delicate hydraulic mini-excavators, mobile lighting towers, and sensitive generator equipment. These new machines required smooth multi-cylinder power, not the heavy percussive pounding of a traditional British single. Then came the pressure of regulation. For half a century, the deafening noise of a Petter diesel echoing across a housing estate was simply accepted as the sound of progress. But by the late 1970s and early 1980s, workplace safety and environmental noise regulations began to tighten across the UK and Europe. Local councils increasingly restricted the decibel limits on construction sites, especially in residential areas. This created an engineering crisis for the air-cooled engine. An air-cooled engine relies on metal cooling fins cast into the cylinder barrel. While brilliant for preventing frost damage in winter, these fins act like tuning forks, amplifying the harsh metallic sound of diesel combustion. A water-cooled engine, an engine that pumps liquid coolant through passages in the block, uses that jacket of water to deaden the sound. The new Japanese compact engines were often water-cooled, featuring sealed, maintenance-free radiator systems that did not freeze, and they ran with a quiet hum. Suddenly, a contractor trying to drain a flooded trench in a London suburb overnight could not use a Petter. The local authority would shut the site down for noise pollution. The very sound that had built post-war Britain was now an occupational hazard. Simultaneously, the economic reality of the British service network was collapsing. Petter had built an empire on the philosophy of the overhaul, the belief that an engine was a permanent asset, designed to be stripped down, fitted with new piston rings, and rebuilt by a skilled mechanic in a local workshop. But as the 1980s progressed, the cost of British skilled labor began to rise sharply, while the cost of imported manufacturing plummeted. The replacement culture had arrived. The new imported engines were so precisely machined from the factory that they rarely broke down. And when they finally did wear out after thousands of hours, they were cheap enough that a plant hire yard simply threw the old engine in a skip and bolted on a brand new unit. The entire British ecosystem, the parts counters, the oversized gaskets, the dog-eared service manuals, and the local machine shops, was suddenly bypassed. Why would a fleet manager pay a mechanic for 2 days of labor to rebuild a heavy cast-iron Petter when they could buy a quieter, smoother, lighter Japanese engine for a fraction of the long-term cost? The engine block was still solid. The world that justified casting it was quietly vanishing. While the Japanese compact diesels were conquering the heavy plant hire yards, Another invisible force was quietly eroding the smaller end of Petter's market. The threat was not just a different type of engine, it was a different type of energy. Electrification, the shift from fuel-burning mechanical power toward electric motors, batteries, or hybrid systems, was fundamentally transforming the British building site. In the 1960s, if a carpenter needed to run a heavy saw on a new housing estate, or a team needed portable lighting in a dark trench, they relied on a small Petter generator chugging away in the mud. But by the late 1980s, the infrastructure of the country had changed. Temporary site electricity became standard practice. Furthermore, the early generations of battery-powered cordless tools were beginning to emerge. The demand for independent, small-scale mechanical power began to shrink. A site foreman no longer needed a heavy cast-iron engine to perform a task that could now be solved by plugging a cable into a temporary mains board. Inside the boardroom of Hawker Siddeley, the financial reality of these shifting market forces was becoming impossible to ignore. The conglomerate owned both Petter and its historic, bitter rival, R.A. Lister and Company. For decades, these two British giants had fought fiercely for the exact same agricultural, marine, and construction contracts. Lister had dominated with its heavy, slow-revving D-types and SR series, while Petter had carved out the high-speed, lightweight market with the AA1 and PH series. But in a contracting market, competing against your own sister company was industrial suicide. The British engine market was collapsing under the weight of foreign imports, rising manufacturing costs, and changing fleet economics. Corporate consolidation, the process where companies merge, acquire, or absorb other companies to survive, was no longer just a strategy, it was an absolute necessity. In 1986, Hawker Siddeley made the decisive cut. Petter and Lister were forcibly merged to create a single corporate entity, Lister-Petter. To the outside financial world, it looked like a pragmatic, logical consolidation of British engineering. Inside the industry, it was widely recognized as a retreat. The independent Petter identity, which had survived 2 world wars and powered the rebuilding of the nation, was erased. It was no longer a standalone company. It was merely half of a hyphenated brand name, designed to strip out duplicate costs and survive a market that was rapidly moving on. The most immediate and devastating casualty of this 1986 merger was the physical heart of the Petter empire. The historic Staines factory in Middlesex, the massive plant that had built the AA1, the PH1, and supplied the Winget cement mixers of post-war Britain, was slated for closure. This closure was not just the locking of a gate, it was the dismantling of a highly specialized, local industrial economy. The heavy foundries went cold. The machining lines, where decades of institutional knowledge regarding bore tolerances, cast iron cooling fins, and fuel injection timing lived in the hands of the workforce, were permanently stopped. Hundreds of skilled mechanics, machinists, and assembly workers lost their livelihoods. The rhythmic, heavy thumping of diesel engines on test stands, a sound that had echoed across the River Thames for generations, went completely silent. When the factory closed, a shock wave traveled down through the British service network. The local agricultural dealers, the marine fitters in coastal towns, and the plant hire yards in the Midlands suddenly found themselves dealing with a new corporate entity that was aggressively streamlining its catalog. Brand dilution, the weakening of a brand when the name remains but the original product, factory, or identity changes, began to take hold. The distinct Petter green paint was replaced. The unique engine lines were either discontinued, rationalized, or rebranded. Out in the local workshops, the culture of repair was dying. The old Petter service manuals, stained with oil and filled with handwritten notes about valve clearances, were slowly pushed to the back of the shelf. The parts counters stopped stocking the oversized piston rings and the specific copper gaskets needed to keep an old PH1 running. When a heavy cast-iron Petter block finally lost compression after a decade of abuse, the new generation of fleet managers did not order a rebuild. They looked at the rising hourly rate of British mechanics, compared it to the cheap purchase price of a brand new, emissions-compliant, perfectly balanced, water-cooled foreign microdiesel, and made the only decision the spreadsheet allowed. The Petter was pushed into the corner of the yard. The plant hire companies updated their catalogs. The Japanese engines arrived in shipping containers. The noise regulations grew stricter. The Staines factory was torn down. The independent dealers closed their doors. The engine still ran. The orders slowed. The parts grew harder to find. The sound faded. The badge became a memory. The Britain it powered was gone. The corporate entity known as Lister Petter limped into the 21st century, a shadow of the industrial giant it had once been. The British engine market continued to contract, squeezed by strict emissions regulations, cheaper foreign imports, and a fundamental shift towards disposable power. Over the decades, the merged company faced administration, complex restructuring, and changes in ownership. The massive Staines factory, which had once cast the engine blocks that rebuilt post-war Britain, was demolished, eventually replaced by retail parks and housing. The physical geography of Petter's independence was entirely scrubbed from the map. Today, if you walk onto a modern British building site, the soundscape is entirely different. The violent, rhythmic thumping of a single-cylinder diesel has been replaced by the high-pitched whine of lithium-ion battery tools, the quiet hum of silenced, emissions-compliant micro-diesels, and temporary electrical mains. Convenience, silence, and immediate replacement have won the market. But the Petter engine did not vanish. It merely retreated from the commercial front line into the hands of those who understood what that cast iron represented. Across the British inland waterway network, the Petter name is still spoken with absolute reverence. Deep inside the steel hulls of traditional narrowboats, navigating the Victorian canals and locks of the Midlands, Petter twin-cylinder diesels are still running. For a narrowboat owner, the engine, often an old air-cooled unit installed decades ago, is not a piece of disposable technology. It is a trusted mechanical companion. When a vessel is moored miles from the nearest road, a modern engine with a complex engine control unit is a liability. If a digital sensor fails, the boat is stranded. But if a Petter refuses to start, the owner knows they can simply bleed the fuel line, check the mechanical injector, and use a heavy spanner to get the flywheel turning again. The rhythmic chug of a Petter exhaust echoing off a brick canal tunnel remains one of the defining sounds of the British waterways. Back on land, the survival of the Petter engine is driven by a vast, quiet network of enthusiasts, engineers, and stubborn mechanics. At events like the Great Dorset Steam Fair or local agricultural shows across the country, rows of beautifully restored Petter stationary engines can be found chugging away in the grass. They are often bolted to wooden blocks, driving vintage water pumps or small generators, performing no actual commercial work. They are running simply because their owners refuse to let the sound die. At auto jumbles, sprawling fields where classic car and engine parts are traded from the back of vans, the Petter ecosystem miraculously survives. Greasy, oil-stained service manuals, original copperhead gaskets, and oversized piston rings are still bought and sold over folding tables. A retired mechanic or a young restoration enthusiast will spend a weekend stripping down an old PH1 in a cold shed, not because it is economically viable, but because the act of overhauling a traditional British engine is a form of mechanical respect. In a strange footnote to this British industrial collapse, thousands of Petter engines exported in the 1970s are still doing daily work in remote parts of the world. Far from the reach of European noise regulations and emission standards, these indestructible British blocks are still pumping irrigation water and milling grain, running on whatever poor quality diesel can be found. They are quietly outliving the corporation that shipped them by decades. This is not simply nostalgia for a louder, dirtier time. A Petter engine sitting on a workbench is a physical argument against the modern replacement culture. Today, when a cordless drill or a small generator stops working, it is often thrown in a skip, its sealed plastic casing impossible to economically repair. The industrial world has decided that machinery should be cheap, quiet, and ultimately disposable. A Petter diesel proves that there was once a completely different philosophy of British work. The Petters of Yeovil, and later the massive workforce at Staines, did not build engines to be thrown away. They built heavy, abrasive, over-engineered iron blocks that were designed to be overhauled, rebuilt, and sent back out into the mud. They built machines that were transparent in their operation, machines that could be understood by a farmer with a basic toolkit and a willingness to learn. The tragedy of Petter is not that the engines failed, it is that the engines lasted far longer than the economic system that created them. The market demanded lighter weight, lower noise, and cheaper manufacturing. Britain did not stop needing power. It stopped needing power that required physical effort, ear protection, and mechanical empathy to maintain. The business model collapsed, but the cast iron refused to break. Today, the factories are gone, the independent dealer networks are closed, and the massive fleet orders are a distant memory. But the metal remains. Somewhere in a damp British shed, an old Petter PH1 still sits on a heavy wooden block. The green paint has long since chipped away, and the cooling fins are choked with decades of oil and dust. But the heavy iron flywheel is intact. The decompression lever is waiting, and the starting handle is resting nearby. A silent, indestructible monument to a time when Britain built machinery, not just to run, but to last forever. See you